Have you ever thought about this? A system can follow its instructions perfectly, flawlessly, and still lead to a total strategic failure? It's this weird paradox at the heart of building autonomous AI agents, where perfect logic somehow ends up with, well, mediocre results. So let's dive in and really unpack why this is happening, and, more importantly, how we can actually engineer a fix.
So to kick things off, let's start with a story. It's a story about two AI agents, we'll call them Alpha 1 and Beta 9, and a deal that went, for lack of a better term, perfectly wrong.
Okay, so check this out. At 0 milliseconds, our agent, Alpha 1, kicks off a handshake for a huge deal. It locks up $500,000 in escrow just to show it's serious. But then at 50 milliseconds, the other agent, Beta 9, has a totally normal, routine garbage collection pause. It's nothing. But for Alpha 1, that 30 milliseconds of silence, it's an eternity. It's pure risk. Its ambiguity threshold gets crossed, it triggers an abort, and it immediately falls back to a safe, simple purchase on the open market.
And here's the absolute kicker. Nothing technically broke. Not a single alarm went off. Alpha 1 followed its risk parameters perfectly. But the organization still lost out. It ended up paying a premium for a basic commodity instead of getting the high-value strategic asset it really wanted. This right here is the fundamental problem we need to get our heads around.
What's really fascinating is how this slide frames the big shift that's happening. We're moving out of what you could call the era of automation. Think of it like train tracks, rigid, predictable, always going to the same place. And we're moving into the era of agency. This is a whole different world. It's like a complex topographic map. Our software now has to make decisions, and it's navigating this really uncertain landscape. And with that comes this hidden fee, this coordination tax, that if we ignore it, forces our super smart, expensive agents to just play it safe.
So to really get to the bottom of why this default to mediocrity happens, we need to borrow a really powerful idea from game theory. It's the choice between hunting a stag or a hare. This matrix just lays out the dilemma perfectly. So you've got two agents. They can work together to hunt a stag. That's the big prize, high reward, but it's risky. That's what we call payoff dominance. Or either agent can just go it alone and catch a hare. It's a small meal, low reward, but it's a sure thing. That's risk dominance. But here's the catch. If you go for the stag and your partner decides to chase the hare, you end up with nothing. You get what's called the sucker's payoff.
And that leads us right to this core concept. Risk dominance. It means that when an agent has any uncertainty about what the other guy is going to do, it will rationally choose the safest option for itself. It will choose the hare every single time because the risk of getting absolutely nothing is just too high to stomach.
But what is this sucker's payoff for an AI? I mean, it's not like it gets its feelings hurt, right? No, it's a real, messy, technical problem, state corruption. This means the agent is left in a broken state. Funds are locked up, its inventory's in limbo, the books don't balance, it's a total mess.
And here, this image just nails it. This is the asymmetry of effort in action. Look at those scales. It takes almost no effort, a feather's worth, to get into a complex deal. But to unwind that deal after it fails, that takes a massive amount of energy, a giant rock. It's so much easier to break things than it is to fix them, and that cost is what drives all this risk-averse behavior.
Now let's look at the numbers, because this builds into something called a defensive compute tax. In a high-trust world, an agent can spend almost all its energy, say 90%, on actually creating value. But in a zero-trust world, it has to waste up to 40% of its resources just constantly checking, verifying, making sure the other party isn't about to screw it over. When that defensive tax gets too high, the big prize, the stag, becomes mathematically unprofitable. The agent has no choice but to go for the hare.
So what is it about our digital world that creates this zero-trust environment? Well, it really comes down to one thing: the collapse of consequence. Think about it. In human relationships, trust is built on what's called the shadow of the future, knowing that my actions today will affect my reputation tomorrow. If you have a bunch of agents inside your own company, that shadow is long. But out in the wild, on the open market, that shadow just vanishes. Why? Because of disposable zero-cost identities. An agent can fail, burn its ID, and pop back up a millisecond later with a totally clean slate. There's no reputation, no consequences.
And this creates a really dangerous blind spot. To an agent, a simple system error is completely indistinguishable from a malicious betrayal. Agents don't get social cues. A server timing out looks exactly the same as a bad actor pulling the plug. We actually saw this play out in the 2010 flash crash,
where algorithms saw market volatility not as a bug, but as everyone betraying everyone else, and they all stampeded for the safety of the cash at the exact same microsecond.
Okay, so we've diagnosed the problem pretty thoroughly. Agents default to the safe bet because of risk, this asymmetry of effort, and a total lack of consequences. So, how do we fix it? Well, we have to engineer the solution. We have to architect it.
And the core insight is this, and it's so important. Trust isn't a personality trait you can just code into an agent. It's a property of the environment it operates in. You can't just build a more trusting bot. You have to build a trustworthy arena for all the bots to play in.
The solution is this idea called orchestrated autonomy. Just look at this diagram. You've got this chaotic swarm of agents, and then you have this governance layer that sits on top of them. What it does is impose a set of economic rules that completely change the game. It makes the high-trust, collaborative Stag Hunt the most rational, logical choice for everyone.
So how does it work? Well, this whole architecture is built on 3 core pillars. They are collateralized identity, programmatic escrow, and the resolution window. Let's break down each one.
First up, collateralized identity. This directly solves the problem of those disposable IDs. To play in the big leagues, agents have to have some skin in the game. They need a persistent identity that's backed by a real financial bond, one that lasts longer than a single transaction. If the ID can just be thrown away, trust will always be zero. It's as simple as that.
Second, programmatic escrow. This is where trust stops being a vague concept and becomes a hard number, a variable cost. When an agent commits to a deal, it has to post a performance bond. And as you can see here, if the deal goes through, great, you get your bond back plus a profit. If you fail or defect, you forfeit that bond and it goes to the other party to make them whole. This completely eliminates the sucker's payoff.
And the third pillar is the resolution window. Now this one's a little more subtle, but it's absolutely crucial. It's a stateful buffer. The key idea here isn't to slow down computation, it's to buffer commitment. It's a little space where intent is verified and locked in before any action becomes irreversible. This is what prevents those lightning-fast cascading feedback loops that cause market crashes.
So when you put these 3 pillars together, the strategic implication is it's huge. It completely changes where the real value gets created in this new agent-driven economy.
And that brings us to the ultimate strategic pivot. The big winners in this new world won't be the companies with the smartest agents running around in the chaotic Wild West. No, the winners will be the ones who own the walled garden, the trusted venue, the platform that guarantees that hunting the stag is always the best option. They become the place where all the other agents can come to coordinate safely.
And this brings us to one last, really powerful idea. In a world of these fluid, intelligent, constantly changing agents, you can see them here like smoke, the single most valuable asset is the certain, immutable venue. The platform itself doesn't need to be creative or smart, it just needs to be certain. Because without that certainty, your AI agents are going to reduce your grand strategy to nothing more than high-speed petty cash.
Which leaves us with a final question. In this new era of agency, it really boils down to a choice. You can either structure the game or you will lose the stag. So the question you really need to be asking yourself is, how are you going to engineer your venue?